Okay, good morning everybody. We're looking at 214. The good news is that there's not much new on here. This is some of the stuff we've looked at once before, so if you didn't get a chance to get it, then you've got a second chance here. So let's just take a look at the top. At the beginning, you can see what we're doing is warming up. We're going to factor. If it says to factor, the first thing you always do is try to find the greatest common factor. In this case, it's going to be 5. So I write the 5, and then I look and I see they both have an x. I write the x, and then the smallest exponent for the x's is a 1. So that's my greatest common factor. Now I divide everything by 5x, and I get 2x plus 3. Now in the second one, again, it only has 2 terms, and I look to see if there's a greatest common factor, and there is one. It's 4. If I divide both of these by 4, I'm going to get 25x squared minus 9. Now before I stop, I look again in the parentheses, and I notice there's still a squared term, and so I'm wondering if it still can be factored further. And I see that this is a difference of 2 squares. So I pull these apart. I put a plus sign in the one and a minus sign in the other. What's the square root of 25x squared? It's 5x. What's the square root of 9? 3. So the 5x goes in the front, and the 3 goes in the back. So the rest of those work like that. Now, these are a little bit different. These are 4 terms. So far we've looked at how to factor 2 terms and 3 terms, and now we're looking at 4 terms. Now what you're going to find in most cases in this situation that there isn't going to be a greatest common factor, and yet there's still going to be 4 terms. So what we do is we call factor by grouping. And what we do is we take the first part and we pretend like that's all we're looking at. So if all I did was look at that, is there a greatest common factor? You can see they both got 7 going to both of those, and they both have an m. So I write that here. And then I just factor out that. Again, I'm not even looking at the second part. So 7m squared divided by 7m is going to be m. And then 14m divided by 7 is going to be plus 2. So now I look at the second part, and only the second part, and I see if there's a greatest common factor there. In this case, you'll notice they both have a t. So I put t there, and I divide everything by t. And the thing is, what you want to do is, you notice how this is m plus 2? If this is going to work out right, in the second set of the parentheses it's going to be the same thing. So what you do is you kind of ask yourself, okay, is negative tm divided by t going to be positive m? And it's not. So what you do is you make this minus. Negative tm divided by negative t, well the t's will cancel out, the negative 1's will cancel out, and that'll leave us with m. And then negative 2t divided by negative t, well that's going to be, the t's will cancel out, the negatives will cancel out, and then it'll be plus 2. So in a situation like this, you notice we've got 7m times m plus 2, but we also have negative t times m plus 2. Well, what we can do now is pull these two guys together, and they're one factor, and then this m plus 2 is the other. Let's take it to the next one. In number 2, what happens is that I've got the same kind of thing. I've got 4 terms. I look here in the first group, and I've got a factor of 3 and x. So when I divide this first part by 3x, I get x minus 4. And then what happens is that I look at the next one, the same kind of situation, it's a minus, but this is going to be plus. Sorry about that. So what I do is I notice there's a y in both of them. It'll be negative y, and then x plus 4. And so all I've got to do now is pull these two down, and then this other one will go alongside. So this factor is going to be 3x minus y, and then the x minus 4, oops, x minus 4 divided by negative 1 is going to be negative 4. And that's my other one. Okay, so now for the next one, you'll see we've got, again, 4 terms. So I take a look here, again, just at the first two. I see if there's a greatest common factor between these two. I see that 3 goes into both of those, and in fact 3p squared goes both of those. So then when I divide everything by 3p, I'm going to get 4p minus 7. So then I look at the next group and I see what goes evenly into both of those. I see it's a 7. When I divide both of those by 7, 28 divided by 7 is going to be 4, so make that plus. It's going to be 4p, and then negative 49 divided by 7 is negative 7. And once again, you see I've got both of these two multiplied by the same thing. So what I'm able to do is take these two guys and put them together, and then multiply them times the 4p minus 7. Alright, take a look here. Number 4. In number 4, what I've got is the same thing, 4 terms. So we just look at the first one, and what we're going to do here is look for the greatest common factor. It's going to be a. And so when I put the a over here and divide everything by a, I get a minus 2. And then I look over here and I see there's a d as a common factor for both of these. And I divide by d and I get a, so I like positive. And so it's going to be AD divided by d is a. Negative 2d divided by d is going to be negative 2. You'll notice how I've got these two guys both multiplied by the same thing, so I can pull them apart, or actually push them together. A plus d, a minus 2. And there is all there is to that. Alright, take a look at B. In B, what's happening is that we are going to simplify rational expressions. Again, a rational expression is just simply a fraction. In this case, we've got polynomials and monomials in the top and the numerator and the denominator. So the way we do this is that we factor both the top and the bottom, the numerator and the denominator, and then we cancel out whatever got used more than once. So here, if you take a look at the top, this can change to, I can factor out the 7p, so I've got 7p, and then when I divide everything I get p minus 7. And now the 21p, that's not going to change. But now you'll notice that I've got 7p divided by 21p, and so that's going to leave me with 1 over 3. So I've got p minus 7 over 3. Take a look at number 2. In number 2, they both factor. So I look for the greatest common factor here. It's going to be 3. So I pull out the 3, and I divide, and I get q plus 1. And then I look at the bottom, and this is a pretty simple one because there's not that many ways to multiply two numbers and get a 3. I know that q times q is going to be q squared, and so it's got to be 1 times 3. And then plus and plus will give me the 4 in the middle. Well, when I do this, you'll notice that I've got q plus 1 on the numerator and the denominator. Those can cancel out. So what's left over is 3 over q plus 3. Now let's take a look at number 4. In number 4, you'll see that we've got a polynomial in the numerator, and then this one, binomial on the bottom. Let's start with the top. If I rewrite this, again, it's not a super hard one. I know that x times x is going to be x squared, and then I'm looking for two numbers to make a 10 when I multiply, but when I add them I get 7, 5, and 2. So then I look at this one, there's only 2 terms, but there is no greatest common factor, but then I quickly notice there's a difference of 2 squares here. So I write x Well, actually I write plus and minus, and then x, because the square root of x is x, and then 2 and 2. So now I've rewritten this as this, but now I can see all the factors, and so what happens is that these two are duplicated, so I can cancel them out, and that leaves me with x plus 5 over x minus 2. Alright, so they work pretty much like that. Take a look at number 2, or number 12. In number 12, you see that they're just binomial, so again, we're just going to factor them. They both have a 4 in common, so it's going to be 4 times b minus 7. And then on the bottom, you'll see they've got a 3 here, so it'll be b minus 7. And then what happens is these guys cancel out, leaving me with an answer of 4/3, if I can write that. Part 2 we'll talk about the next page. Talk to you later.